let's go through the code 146 LRU cache, and the question let us to design a data structure that follow the constraints of our LRU cache, and it need to for the LRU cache it has a positive size capacity, and it let us to implement two methods. One is get, another is put. For the get method, if the key exists, we return the value, otherwise return -1. For put, we'll update the value key if the key exists, otherwise add the key value pair to the cache. And also, if we have the get or put method, those kind of key value pair will be most recent use. And in the operations which cause the key value pair greater than capacity, will evict the least recent use key. We know that get will not get it will not add new values, right? So it will not have the evict operations. Only the put may have the put when it has the new key added, and also it exceeds the capacity. It will will have the evict operation, and it let us to have O1 time complexity for all of the method. We know if we do not have O1 time complexity, possibly we can just use a map, right? And maybe have a counter and trying to iterate the map, the case, right? But we want to have the O1 complexity, the things that so we need to have some kind of we need to have the O1 operation to find the key value pair, and also get the size. For example, all of the operation like get size, like add the key value pair, and also update the frequency, right? Update the most recent one, and also remove the capacity will all be the O1 complexity. So what we think about this kind of question is that we can use a linked list and also a map to do that question. Now, what the map store? Map, it will have the key will be our key, right? This get key, and the value will be our linked list node, and we are going to use the double linked list here because we want to have some kind of insert and delete operations. If we use linked list for the delete operation, right? So for example, if we store the key, and the value will be the linked list. If we just singly linked list, for the delete, we need to find its previous linked list. The map will store the key and its previous linked list, and then let its previous linked list to connect to this kind of linked list next. It's not that straightforward. So so we can use a double linked list so that we find this one, and we just use this linked list pre to get its pre node, and its next to get its next. When we delete, just connect the pre and next. So it will be more straightforward. So let's begin to write code for this. we're going to use class called list node. We can write this outside. And as per we talked about this linked list, we are going to put this one as doubly linked list. So we'll have a link this node 3 in the next. And also this one need to have the key value pair, right? Int key value. And let's put the constructor here. Int key value is dot key dot key is dot value plus value. So what we are going to do is that we are going to have a list node head and tail, right? The reason we create two and a head tail here is that we have two dummy nodes, one is head and the tail, right? And every operations for the put key or delete when it exit the capacity, we just manipulate the linked list in the middle part. It will not have some kind of scenario we delete the last one, because the last the tail list node, the operations will be different than the middle one, and also the head, the same thing, right? So we create two dummy nodes, one is the head, one is tail. And we are going to have a map. The map here is to help us to use O1 time complexity to find a list node. So let's initialize it. Let's say head equals new list node. We'll have -1 and so on, right? Yeah, because new list node -1 -1. We'll have a head dot next equals tail, and tail dot pre equals head. And also we need to have the map with new cache map. And for this question, it also have a variable called the capacity. So here, we need to use this capacity in our put function, right? When it exits the capacity, so we can have a variable called capacity. I have this dot capacity equals capacity. So let's begin to implement the get function, right? So we'll say if the map contains this key, we'll just get it. And also we'll do two things, move this kind of node just to the front. I mean front, that is the node just after the head. So we'll write if this map doesn't contains, right? Map doesn't contains key. Right. We just return -1. Else we'll have get this node out. With this key, right? Um, and also we need to move this node to front. We can actually write we can create two help functions. One is delete node, right? Another is add node. And then return this node dot value. Delete node will delete those node just this node in the double linked list, right? Just remove it. So what it doing is that it will reconnect, and also we are going to delete the key value pair from the map. Add a node, well, we'll just add a node after the head, right? And also add a key value pair to the map. So this will be get, and we'll also need to have the delete, right? Node. Mm. And when for the put, right, put that we also need to check whether map contains key or not. So if map contains key, right, then we just need to add. Just need to update, because if it contains key, there is no new node added to the double linked list, so it will not exceed the capacity. We just need to get the node and update its value. So so what we need to do is the list node. We get this node and update its value, and also there is another operation is that we need to move this one to the first one, because first one after the head, right? So we get this node equals map get key. We will write the what we do here, right? Remove node from double linked list, right? And also remove from map key, right? Entry from map. And for add, right? Add is that add node after head, and add entry to map. So we know if we have this one, we get this one, we can update this node dot value equals value, and we just delete this one from the linked list. Now we saw add this one, right? Add this node. Every time we add, we will get this one, just the first one, first node after the head. So it will also get it to be most recently used. Else, if this one doesn't have this key, then we'll create a new list node, right? List node equals new list node key value. And we are going to add this one, add this node. And we'll say, when we add this node, right? So we know this one already, we put the logic add entry to the map. So we can find whether our size is current size to is greater than the capacity. We know we can have the current size to be map.size, right? So that we don't have an actual variable. So we'll say if map.size is greater than capacity. What we are going to do is that we need to get the this recent use, that is the node which is before the tail, right? So we'll have a list node oldest equals tail dot pre, and we're going to delete oldest. Yeah. So let's implement the delete function in the add function. Delete function is that from because we already have the head and tail, we know every node it will have the pre and next, right? So we'll have list node pre node, right? We can put pre node equals node dot pre, and list node next node equals node dot next, right? And we'll have pre node dot next equals next node, and the next node dot pre equals pre node. And also we need to remove this key value pair from the map. So map remove node dot value, right? Node dot key. And for add is that we'll find the one we'll add to the just the one after the head. All right, so we'll get the current head list node current and current recent, or let's call it the next node, right? Was head of the next, and we'll have the head of the next equals node, and the node dot pre equals head, and also node dot next equals next node, and the next node dot pre equals node. And also we need to add this on to the map. That is the map put node dot key in the node dot value. This one will be value, right? Anything else? 17. Next. uh, Actually, we put it, what we put is a node, not a value, right? So let's try to see this one has been passed any other. Which one is if there is any? Yeah, this kind of operation, the every operation that will be O1 time complexity.